if step of square root of n square plus 1 is equals to step of square root of n square plus lambda. This is step. Here denotes greatest integer function, where n comma lambda belongs to capital N, that is natural numbers. N comma lambda are natural numbers. Then show that lambda can have 2n different values. Lambda can have 2n different values. This is the question. From this, I will start the solution from here. Now you take this n square plus 1. N square plus 1 can be written as, because n is what here, n is a natural number, n square plus 1 can be written as n plus 1 whole square minus 2n, because n square plus 1 plus 2n minus 2n cancel. This is equal to this one. So this n plus 1 whole square minus 2n is always less than n plus 1 whole square. This implies from this one, n square plus 1 is less than n plus 1 whole square. And this n square plus 1 is always greater than n square. This is first observation, this is second one. So from 1 and 2, from 1 comma 2, this n square plus 1 lies between what? N square and n plus 1 whole square. From 1 to n square is less than, n square plus 1 is less than n plus 1 whole square. From 1 and 2. So square root of n square plus 1 is there. Therefore square root of n square plus 1 lies between what? N square plus 1 is less than n plus 1. Is that n is a natural number. Now from this one, what is the step of this one? Step of n square plus 1. This n and n is a natural number. Since n is a natural number, so these two are two consecutive integers, that is natural numbers. Here n is a natural number, two consecutive natural numbers. Therefore step of square root of n square plus 1 equal to what? This n. Step of n square plus square root of n square plus 1 is equal to n. Next, our right hand side is what? In our question, right hand side is what? Square root of n square plus lambda is there. Therefore both are equal, but the question is what? Question is square root of n square plus 1 step is equals to square root of n square plus lambda. So what we got? The step of n square plus 1 is n, that is n is equals to step of n square plus lambda. So now tell me, from here only, a step of n square plus lambda is equal to n means what? Step of n square plus 1 lies between what? N and n plus 1. This implies when this is equal to n, when that implies n is less than n square plus lambda, that is this thing. This n square plus lambda is less than n plus 1. Then only this step value is equals to n. This implies if you square on both sides, n square is less than n square plus lambda is less than n square plus 1 plus 2n. This n square cancel. This implies 0 is less than lambda is less than what? 2n plus 1. So our requirement is what we need to prove. Lambda can take 2n different values. Yes, lambda lies between what, 0 to 2n plus 1. Therefore lambda is also natural number. Therefore lambda natural number. Therefore lambda takes greater than 0. The lambda is a natural number. 1 starts with 1. 1, 2, 3, etc. 2n plus 1 is a natural number, but here greater than, strictly inequality is there. 2n plus 1 is strictly greater than lambda. Therefore this preceding integer natural number is what, 2n. Therefore lambda is equal to 1, 2, 3, etc. 2n. Therefore lambda can take 2n different values and natural numbers. This is question number